Good morning, my dear students. Today, I'll teach you the first chapter of your book, Essential ICSE Mathematics. The name of the chapter is Concepts of Sets. Set. A set is a collection of well-defined and distinct objects. Every object of the collection forming a set is called a member or an element. The objects must be well-defined. When an object is a member of the set, we say that the object belongs to the set. Example: the months of a year, days of the week. Notation of a set. The sets are denoted by capital letters like A, B, C, etc. The members of the sets are denoted by small letters like B, C, D or numbers, etc. The set of natural numbers is denoted by capital N, and natural number starts from 1, 2, 3 and goes up to infinity. The set of whole numbers is denoted by W, and it starts from 0, 1, 2, 3 up to infinity. The set of integers is denoted by capital Z or capital I. It includes all the negative numbers, 0 and all the positive numbers. Representation of a set. The first method is roster method or tabular form. The set A of first four natural numbers is written as A is equal to, in the curly bracket, 1, 2, 3, 4. The second method is rule method or set builder form. Given set A is equal to 1, 2, 3, 4, 5, 6. So, in the rule method, we can write the set A is equal to x such that x is a natural number less than 7. The line between the two x is pronounced as such that. Types of sets. Finite set. A set is called finite if the elements of the set can be counted. Example: A is equal to 1, 2, 3. It has 3 elements. Infinite set. A set is called infinite if it has countless elements or members. Example: the set W of whole numbers. The whole number starts from 0 and goes up to infinity. Empty set. The set which has no element is called an empty set or null set. It is denoted by the curly brackets without any element in between or the symbol phi. Phi. Universal set. The set of all objects under consideration is the universal set for that discussion. The universal set varies from problem to problem. It is denoted by capital U. Cardinal number of a set. The number of distinct members of the set is called its cardinal number. It is denoted by n of set A. N bracket A. Example: if A is equal to 1, 3, 5, 6, 8, then n of A is equal to 5 because the set A has 5 distinct members: 1, 3, 5, 6 and 8. If the cardinal number of set A, or we can say if n of A is equal to 1, we call the set as singleton set. Pair set. If n of A is equal to 2, we call the set A a pair set. Example: A is equal to x such that x is the outcome of a coin tossed. So A is equal to heads, tails. Equivalent sets. Two finite sets with equal number of members are called equivalent sets. If n of A is equal to n of B, then A is equivalent to B. Example, set A is equal to 1, 2, 3, 4, 5 and set B is equal to A, E, I, O, U. So as you can see, both the sets A and B are having 5 elements. So n of A is equal to n of B. So A and B are equivalent sets. Equal sets. Two sets A and B are said to be equal if every member of A is a member of B. Example, let A is equal to 2, 4, 6 and B is equal to x such that x is an even natural number less than 7. So B will be equal to 2, 4, 6. Thus, every member of A is a member of B. So, A is equal to B. Venn diagrams. A set is represented by a circle or an oval-shaped closed curve. The members of the set are represented by points inside the figure. So, as we can see from the first figure, set A is represented by a circle and an arrow is pointing inside the circle. Objects here are in set A and one arrow is pointing outside the circle. Objects here are not in set A. From the second figure we can see set A. Inside the set A circle we have zebra, chair, cat. So we can say that zebra, chair and cat are the elements or the members of set A. But the terms like John Venn, octopus and tripod are outside the circle, so they are not the members of the set A. In the given diagram of two circles, we can see that A and B are overlapping over each other. The middle portion represents the common element between A and B. In the second diagram, as we can see, set A is having the elements like 1, 3, 5, 7, 9 and the set B is having the elements 6, 7, 9, 8 and 10. The two elements 7 and 9 is common in between set A and set B. So 7 and 9 is represented in the area which is common to set A and set B. 2 and 4 are not given in the circle of set A, neither in the set of circle B. So 2 and 4 does not belongs to A and they also does not belongs to set B. So now we are going to start the exercise 1A. So we'll start with question number 1. Which of the following collections are sets? First, all the months of a year. Yes, it is a set since all the 12 months are well defined. Second, all super actors of India. It is not a set because the criteria for super actor is not clearly defined. It can be a comedian or a villain. Third, all the letters of the word Mizoram. So we have to write down the elements of the set at first. So we'll write down A is equal to M, I, Z, O, R, A. It is a set because all the letters of the word Mizoram are clearly defined. You can see that the word Mizoram is having 2 times M, but in the set we have to write it down a single time because the elements of the set should not be repeated. Now question number 2. Let A be the set of all whole numbers greater than -3 but less than 5. Then fill in the blanks by the symbol which is given is known as belongs to or does not belongs to. So we will write down the elements of the set at first. So A is equal to, we'll start with 0, because it is a set of whole numbers and whole number starts from 0. So 0, 1, 2, 3 and 4 because we have to take less than 5. So the elements of set A we have written. Now we have to find out the first part is 0 belongs to A because we can see that 0 is an element of set A. 3 belongs to A. -4 does not belongs to A and 5 does not belongs to A. Now question number 3. Write the following sets by the roster as well as rule method. First, the set of letters of the word terracotta. Here again we will follow the same rule that the elements of the set should not be repeated. So in roster form we can write it down T E R A C O. In rule method X such that X is a letter of the word terracotta. The set of whole numbers lying between -4 and 2. So since it is whole numbers, we'll start with 0. So 0, 1. In rule method, X such that X belongs to W, whole numbers, comma, and X is less than 2 but greater than -4. Question number 4. Write the following sets in tabular form and find their cardinal number. Cardinal number means we have to find out the number of elements in the set. So first part is A is equal to X such that X belongs to capital N natural numbers, comma, and X is greater than -1 and less than 3. So A will be equal to, the natural number starts with 1, so we'll start with 1, 1, comma, 2. So N of A, cardinal number of A is equal to 2. Third part, C is equal to X such that X is a 2-digit number divisible by 15. So you'll write down the set C at first. So C is equal to 15, 30, 45, 60, 75 and 90. So cardinal number of C, N of C. Question number 5. Write the following sets in set builder form. First part is A, E, I, O, U. So as we can see, these are the vowels of English alphabet. So we can write it down like this. X such that X is a vowel of English alphabet. Third part 1, 3, 5, 7. So it can be written like this. X such that X is an odd natural number and X is less than 8. Fourth part, as you can see, it starts with dot dot dot. So it indicates that it contains all the negative integers from infinity till -3, -2, -1 and 0. So we can write it like this. X such that X is an integer and X is less than 1. Question number 6. Identify the finite and infinite set and write the number of elements of finite set. So we have to find out the cardinal number of the sets at first. Finite set is a set in which we can count the number of elements, and in infinite set the number of elements is countless. We cannot count it. So we'll start with the first. Set A is equal to X such that X is less than 4 and X belongs to natural number. So we have to write down the set A in tabular format first. So A is equal to 1, 2, 3. So N of A is equal to 3 and it is a finite set. Third, C is equal to X such that X is less than 5 and X belongs to Z. Z is integers. So C is equal to, we will write down all the negative integers from infinity to -2, -1, 0, 1, 2, 3, 4. It is an infinite set because it contains infinite number of negative integers. Fifth, E is equal to x such that x is less than 1 and x belongs to natural number. We know that natural number starts from 1, so we don't have any natural number which is less than 1. So E is an empty set. So n of E is equal to 0. Sixth part, and it is the most important one, f is equal to x such that x is equal to 1 upon n square plus 1, comma, n belongs to z. N belongs to integers. So if we start with n is equal to 0, in place of n we have to write down 0. So we'll get x is equal to 1 upon 0 square plus 1. So it is equal to 1 upon 1, that is 1. If we write n is equal to 1 or minus 1, so we will get x is equal to 1 upon minus 1 whole square plus 1 or 1 upon 1 square plus 1. In both the cases we will get it equal to 1 upon 2. Similarly, if we go up to n is equal to 100 or minus 100 or n is equal to 1000 or minus 1000, we will get the values as x is equal to 1 upon 1000 square plus 1. If we will go up to 1 lakh also, we will get one value. So it is an infinite set. Question number 7. Identify the empty set, singleton set and pair set. So let me define the sets at first. Empty set is a set which do not contain any element. Singleton set contains one element and pair set contains two elements. So first part is A is equal to, in the curly bracket 0 is written. So 0 becomes an element of the set. So it is a singleton set. Third, x such that x square is equal to 25, comma, x belongs to natural number. So we'll solve the given equation at first. X square is equal to 25. So x is equal to square root of 25. So x is equal to 5 comma minus 5. We get two values, but since x is a natural number and minus 5 is not a natural number, so it will not be considered. So we get x is equal to 5. So the set C contains a single element 5. So it is a singleton set. Fourth part, D is equal to x such that 5x minus 4 is equal to 0 and x belongs to whole number. So we'll solve the equation at first. 5x minus 4 is equal to 0. X is equal to 4 upon 5. So we get x is equal to 0.8. 0.8 is not a whole number. So x here does not contain any value. So D is an empty set. N of D is equal to 0. Question number 8. Let x is equal to x such that x is a letter of the word minister. Y is equal to x such that x is a letter of the word sinister. State which of the following is true and which is false. So we will write down the sets at first and find out their cardinal number. Set x is equal to m, I, n, s, t, e, r. So n of x, cardinal number of set x is equal to 7. Set y is equal to s, I, n, t, e, r. So cardinal number of set y is equal to 6. The first part is x is equal to y. Two sets are equal if the members are same. But as we can see, set x and set y are having different members, so it is false. X is equivalent to y. It is also false because for the sets to be equivalent, the cardinal numbers must be same. Here the two sets have different cardinal numbers, so they are not equivalent. Question number 9. Let P is equal to 1, minus 1, Q is equal to x such that x square is equal to 4 and x belongs to z integers. R is equal to -2, -1, 1. State which one is true and which are false. So we'll write down the sets at first and their cardinal numbers. Set P is equal to 1, -1 and n of P is equal to 2. Set Q is equal to 2, -2. N of Q is equal to 2. Set R is -2, -1, 1 and n of R is equal to 3. Now we'll do the parts. P is equivalent to Q. It is true because both the sets P and Q are having the same cardinal number. Second, P is equal to Q. It is false because although they have the same cardinal number but the members of the sets are different. Third, Q is equivalent to R. It is false because Q and R are having different cardinal numbers. P is equivalent to R. It is also false because P and R are having different cardinal numbers. Q is equal to R. It is false because the members of Q and R are different. P is equal to R. False because again P and R are having different members in their set. Question number 10. If A is equal to 1, 2, 3, 4 and B is equal to A, B, C, D and set C is equal to X such that X is less than 5 and X belongs to natural number, state which of the following is true and which is false. So we have to write down the set C at first because set A and B is already given. Set C is equal to 1, 2, 3, 4 because set C is a natural number and it is less than 5. So as we can see, all the three sets are having the same cardinal number 4, 4 and 4. So first part, A is equivalent to B. It is true because A and B are having the same cardinal number. A is equal to B. It is false because the members of A and B are different. A is equal to C. It is true because the set A and set B are having the same members and the same cardinal number. B is equivalent to C. True because set B and set C are having the same cardinal numbers. Fifth part, B is equal to C. It will be false because set B and C are having different members in their sets. Thank you and have a nice day.